So far in this course, you've learned about how to retrieve data using the select statement and how to manipulate the data using various functions and operators. But there will be some scenarios where you may need something more than the functions and operators to manipulate the data. T-SQL provides some basic programming features such as variables, control flow elements, and conditional execution to handle more complex scenarios. In this module, you will learn how to enhance your T-SQL code with these programming elements. You will learn what the different language elements of T-SQL are and how to use them, what batches are and how they're handled by SQL Server, how to declare and assign variables and synonyms, and how to use the if and while blocks to control the program flow. First, let's see what the different elements of T-SQL are. Like we discussed earlier, so far in this course, you've learned how to retrieve data from a single table using the select clause and how to retrieve data from multiple tables using joins. When you need to create database objects, you need to get an understanding of how multiple statements interact with the server when they're executed. There will be scenarios where you may have to temporarily store values and pass them as parameters to stored procedures, or create aliases and pointers to objects so that you can reference them by a different name or from a different location than the location where they were created. In this lesson, you will learn how Microsoft SQL Server treats collections of statements as batches, how to create and submit batches of T-SQL code for execution to SQL Server, how SQL Server stores temporary objects as variables, how to declare and assign variables, and finally about what synonyms are and how to invoke them. Let's see what T-SQL batches are. Batches in T-SQL are nothing but a collection of one or more T-SQL statements that are submitted to SQL Server client as a single unit. SQL Server takes a batch and executes all the statements in it at the same time when parsing, optimizing, and executing the code. In other words, the entire batch statement is executed before any results are available. This is often more efficient than submitting statements separately because network traffic can often be reduced and the data source can sometimes optimize execution of a batch of SQL statements. Batches are delimited by the client application, and how the end of a batch is marked depends on the settings of your client. The default batch terminator in SQL Server Management Studio is the keyword Go. Go is not a T-SQL keyword but instead a keyword recognized by SSMS to indicate the end of a batch. And when working with T-SQL batches, you need to know that batches are boundaries for the scope of a variable, which means that a variable defined in one batch may only be referenced by other code in the same batch. Even if you're a report writer tasked primarily with writing select statements and not writing procedures, it is still important to understand the batch boundaries since they will affect your work with variables and parameters in stored procedures and other routines. You must declare a variable in the same batch in which the variable is referenced. SQL Server supports different types of batches like explicit batches, procedures, views, etc. An explicit batch is two or more SQL statements separated by semicolons, and a procedure is considered as a batch when it contains more than one SQL statement. And some of these statements cannot be combined with others in the same batch. Now let's take a look at how to create a batch. You can use create view or create procedure statements to define a set of two or more SQL statements and create a batch. Now let's see how to work with batches. We have learned that batches are collections of T-SQL statements submitted as a unit to SQL Server for parsing, optimization, and execution. You need to understand how batches are parsed so that it will be useful in identifying the error messages and the behavior of a batch. Let's say you have two SQL statements in your query editor window in SQL Server Management Studio and you press the F5 button to execute them. When a batch is submitted by a client like SSMS, the first thing that happens is the SQL Server engine takes the batch and parses it for syntax errors. Any errors found will cause the entire batch to be rejected, and there will be no partial execution of statements within that batch. And next, when the batch passes the syntax check, the SQL Server proceeds with the additional steps like resolving object names, checking permissions, and optimizing the code for execution. Once this process completes and execution begins, statements succeed or fail individually. And if a runtime error occurs on one line, the next line may be executed unless you've added error handling to the code. And that is the main difference between syntax errors and runtime errors. Syntax errors cause the entire batch to be rejected, whereas runtime errors may allow the batch to continue even after failure on one line. For example, let's take a look at these valid and invalid batch examples that we see here. In the first batch, everything will be executed successfully, but the second batch throws a syntax error because of the word value. Let's take a look at some examples to see how to work with batches. Let's open a new query, expand the tables, go to numbers table, and then script the table as insert to new query editor window. And let's say the values are 1 and 2. Let's copy the same statement. And let's say 3 and 4. Click on execute, and those values are inserted. Let's change the syntax to value, and let's change the value to 5, 6, and 7, 8. Before we execute this query, let's do a simple select to see what values are in the table. Select that query and click on execute. And as you can see, the values that we inserted earlier are in that table. Let's comment this query and try to execute these insert statements. Click on execute, and it threw an error where it says value. The error occurred in line 3, but the entire batch is rejected and the execution does not continue with the next line. Let's see if it makes a difference if we have this statement before the statement that threw the error. Paste it here and click on execute. It still throws an error. Now let's see if it makes a difference when we add the batch separator keyword go in between the two insert statements. Click on execute, and it says one row affected. Now let's see if there are any values that are added from these two insert statements in the nums table. Click on execute, and as you can see, the value 7, 8 is added to the table. And that is because each of these insert statements is submitted as a separate batch. You can also use the go keyword with a parameter to execute a statement multiple times. Let's say print repeating commands with go, and then say go 10. Select this query and click on execute, and it repeats the same statement 10 times. You don't necessarily have to use the keyword go as a batch delimiter. You can change that in SSMS by going to Tools, Options, Query Execution, select SQL Server, and then you can change the batch separator by specifying it here. Now that we've learned what batches are and how to work with batches in T-SQL, let's see what variables in T-SQL are. Variables in T-SQL are nothing but objects that allow temporary storage of a value for later use. We've already encountered variables previously in this course, and have used them to pass parameter values to stored procedures and functions. In T-SQL, before we can use a variable, it must be declared. Prior to SQL Server 2008, the actual declaration of a variable and assignment of the variable value is done in two separate statements. But starting from SQL Server 2008, variables can be declared and initialized in the same statement. And declaring a variable includes providing a name and a data type. As you have previously learned, variables must be declared in the same batch in which they are referenced. In other words, all T-SQL variables are local in scope to the batch, both in visibility and lifetime. Only other statements in the same batch can see a variable declared in the batch, and a variable is automatically destroyed when the batch ends. For example, let's take a look at this query. In this query, two variables are declared and initialized. The number of rows is declared as the int data type, and the category ID is also declared as int data type. Let's execute this query and see what the results will look like. Let's open a new query and paste the query that we just saw and click on Execute. Let's change the number of rows to 4 and category ID to 1 and see what the results will look like. Click on Execute, and it returned 4 rows with category ID as 1. Now let's see what happens if you have the batch separator between the declaration and initialization of the variables and the actual execution of the stored procedure using those variables. Let's click on Execute, and it throws an error saying that the variable must be declared. That's because this go keyword here separates these two SQL statements into two separate batches, and since this batch ends with this go statement, the scope of the variable number of rows ends here. And since the number of rows variable is no longer available to this batch, it throws an error. Let's delete this batch separator and click on Execute. Now the results are same as we have seen before. Now let's see some more about how to work with the T-SQL variables. Once you've declared a variable, you must initialize it or assign it a value. You can do that using 3 ways. In SQL Server 2008 or later, you can initialize a variable using the declare statement, and in any version of SQL Server, values can be assigned to a variable with a set command or a select statement. Set can only assign one variable at a time, whereas select command can assign multiple variables at a time. In any version of SQL Server, when using select statement to assign a value, you need to make sure that exactly one row is returned by the query. An empty result set when using the select statement will leave the variable with its original value, and if the result set contains more than one result, it will cause an error. Let's take a look at this example. This example shows 3 ways of declaring and assigning values to variables. In the first declare statement, variable 1 is declared as int data type and assigned a value of 99 in the same declare statement. In the second declare statement, variable 2 is declared as nvarchar data type, and then we are using the set statement to assign the value of string to variable 2. In the third declare statement, variable 3 is declared as nvarchar data type, and we are using the select statement to assign the value to variable 3. Let's execute this query and see what the results will look like. Let's open a new query and paste the query that we just saw and click on Execute. And the result set has 3 variables with the assigned values. Now let's comment this statement and see how to use the select statement to assign more than one variables. Let's use a comma here, and let's say variable 2 equals first name. Click on Execute, and as you can see, the variable 2 is now assigned the first name of the HR employee with employee ID 1. Now let's uncomment this statement and see what the results will look like. Click on Execute, and as you can see, variable 2 is still displaying Sarah as its value because that's the latest and greatest value that is assigned to variable 2. Now that we have learned how to work with variables, let's see what synonyms are and how to work with them. Prior to SQL Server 2005, DBAs have been referencing database objects in 4 part names. SQL Server 2005 introduced the concept of a synonym. In SQL Server, synonyms provide a method for creating a link or alias to an object stored in the same database or on another instance of SQL Server. Objects that may have synonyms defined for them include tables, views, stored procedures, and user-defined functions. The use of synonyms cuts down typing long, multi-part server names and can replace it with one synonym. It also provides an abstraction layer which will protect SQL Server statements that are using synonyms from changes in the underlying objects. And synonyms can be used to make a remote object appear local or to provide an alternative name for a local object. A synonym can be created that points to an object that does not yet exist. This is called deferred name resolution. The SQL Server engine will not check for the existence of the actual object until the synonym is used at runtime. Additionally, synonyms can be used only to change data of the object, not the schema of the object. Synonyms can be used with only select, update, insert, delete, and execute commands. And to manage a synonym, you can use the create, alter, and drop commands. Let's take a look at this example. In this example, a synonym with the name dbo.prods_by_category is created in the tempdb table for the production.prods_by_category object in the TSQL 2012 database. And to create a synonym, you need to have create synonym permissions as well as permissions to alter the schema in which the synonym will be stored. Let's execute this command and see what the results will look like. Let's open a new query, paste the query that we just saw, and click on Execute. Let's expand the system databases, go to tempdb, click on Synonyms, refresh it, and as you can see, a synonym by the name prods_by_category is created in the tempdb table. And when you actually execute this query, it calls the production.prods_by_category stored procedure in the TSQL 2012 database, and the result set is produced from that stored procedure. Click on Execute, and it will return the result set. And one thing to remember when you're working with SQL Azure is that cross-database synonyms are not currently supported in it. So far in this module, you've learned about batches, how to work with them, variables, and how to work with variables in T-SQL code, and how to work with synonyms. In the next lesson, you will learn how to control the flow of program using if-else and while statements.